Hey guys, we are winding down here in chapter 8, and we're going to now talk about estimating a difference in proportions. So we've been working hard with confidence intervals and proportions, and now let's see what happens when we're trying to find the difference between two proportions. So, of course, it's going to be building off of our learning from earlier in the chapter and from earlier in the year, too. So we're going to be determining whether the conditions are met, just like we did in the prior section. And then we're going to construct and interpret confidence intervals for the difference between two proportions. So, same three conditions have to be met. So, the random, meaning the data, has to come from two independent random samples. And the independent part is kind of tricky, and we'll talk more about that later. The 10% condition must be met, and it must be met for both of the sample sizes. So, making sure that your sample size is smaller than 10% of the population size. And the large counts condition, and yep, you guessed it, success and failures in both of the proportions. So you have twice the work to do. That's bad news. That's all right, we can do this. All right, so we have a problem here. A Harris Interactive Survey asked independent random samples, so there's that first condition, from the United States and Germany about the importance of brand names when buying clothes. Of the 2,309 U.S. adults surveyed, 26% said brand names were important, compared with 22% of the 1,058 German adults. Let P sub U represent the true proportion of all U.S. adults who think brand names are important, and P sub G represent the true proportion of all German adults who think that brand names are important. First, check if the conditions for calculating confidence intervals are met. Now notice what they did here is instead of saying the difference of the proportions, they're saying that they equal each other. This is kind of dipping our toes into what's called hypothesis testing. We'll talk more about that later. Random. It said right at the beginning, these were independent random samples, so check. The 10% condition. I am positive there's more than 23,000 U.S. adults, and I'm positive there's more than 11,000 German adults. So yes, the 10% condition is met. Now the large counts condition, you gotta do all the work. You gotta do 4 pieces of work here. So the number from the sample for U.S. times the probability of a success, and then same thing for failure, and then same thing for German. So they had to show that math on all 4 parts. I'm so sorry, guys, but look, they're all greater than 10, which means that our 10% large counts condition is correct. Sorry, misfire there in the brain. So remember, our work for confidence intervals, we had a statistic, and then we're going to add or subtract a critical value, Z star, times the standard deviation of the statistic. So we talked about that being the standard error. Well, this time we have the difference in proportions, plus or minus Z star, times the standard deviation. So the standard deviation for the difference of proportions, we actually saw this in a previous chapter. This is a formula, and I believe it's on your formula sheet for the AP test. In fact, I have it right here. Let me double check that. Oh yeah, it's there. So it's on the second page, by the way, if you're looking for it. So no need to memorize that, but it is always kind of nice to see where things are coming from. So the formula for the standard deviation, p hat sub 1 minus p hat sub 2, uses p1 and p2, which are unknown. Which means we have the standard error. So we're going to have to estimate it with the sample data as opposed to the population data. All right, so here's the confidence interval formula in the difference of two proportions. So again, double checking the formula sheet here. The standard deviation calculation is there, but as far as the confidence interval goes, you guys will have to have that idea not necessarily memorized, because the words for confidence interval are put on your formula sheet. So it'll say like statistic plus or minus critical value times the standard error of the statistic. But then you got to know what all that means. So I guess you're kind of memorizing it, and you know what's going to happen, guys. We're going to have to practice for this test. I don't know why I left that screen so quickly. Remember, the Z star value is that critical value that we're going to be finding. So far, we've been focusing on using inference data that were produced by random sampling. The following example shows how to construct and interpret a confidence interval for a difference in proportions from a randomized comparative experiment. Oh my gosh, that's a lot of reading I'm going to do for you here. Here we go. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs, NSAIDs they call them, like naproxen, to help ease their pain. Researchers wonder if taking Valium along with naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatments, naproxen and Valium, or naproxen and placebo. After 1 week, 39 out of the 57 subjects who took naproxen and Valium reported a reduced lower back pain, compared with 43 out of the 55 who took naproxen with the placebo. Construct and interpret a 99% confidence interval for the difference in the proportion of patients like those who would report reduced lower back pain after taking naproxen and Valium versus after taking naproxen and placebo after a week. Okie dokie, here goes. So we're going to be using our formula. First, we have to state what we're looking at, which I know has kind of seemed like redundant because it was so obvious in the previous parts of the chapter. A little less obvious here in the difference of proportions. Excuse me. So we want a 99% confidence interval for P1 minus P2. Excuse me. Where P1 is the true proportion of patients like these who would report reduced lower back pain when taking naproxen and Valium. And then P2 would be the group with naproxen and placebo group. But you did have to state who was who and which order you were subtracting them in. So exam tip here, many students lose credit when defining parameters in an experiment by describing the sample proportion rather than the true proportion. For example, the true proportion of patients who reported reduced lower back pain would be P hat, not P1. So really careful on the language here when you're stating what you're trying to calculate. Gosh, that seems picky, doesn't it? All right, so now we have to plan this out, which means first, we need to know that we have what's called a 2-sample Z interval for P1 minus P2. And now we have to check our 3 conditions. So they were randomly assigned patients. So that's good. They were independent trials. And 10%, yeah, we don't have to check the 10% condition because researchers did not sample patients without replacement from a larger population. So that's kind of tricky. And I have a feeling if you went ahead and said like, the 10% condition has been met because there's more than whatever you were going to come up with, 570 people with lower back pain, or whatever number this all comes out to, I think they would still count you correct. However, you don't even have to check the 10% condition because they were not sampling with, they did not sample without replacement. If that makes sense. Probably not, sorry. All right, and then the large counts condition. Remember what we have to do here is we have to do, this is interesting. Okay, so 39. Now, we don't need to do the proportion work, right? Because we have like the raw data, so it wouldn't make sense for us to go find a proportion of the numbers we already know. So there's 39 successes in the first group, which means there's 18, quote, failures in the first group. And then in the second group, there was 43 successes and 12 failures, all of which were greater than 10. Now, that last one was kind of close, so it was almost not able to meet all the conditions. All right, now it's time to calculate everyone's favorite part. So you have P hat 1, which is the 39 out of 57, and then written as a decimal. And then you have P hat 2, which is 43 out of 55 written as a decimal. So when I use those values and I substitute them into our formula, we end up with that giant mess. Now, again, the formula is given to you, kind of. You have the template for what confidence interval is, and then you have all the pieces of the formula over on the other page. So our confidence interval calculates down to negative 0.312 to 0.116. We have to interpret that now. That's the important part, right? So we had a 99% confidence interval, I believe. So we are 99% confident that the interval from negative 0.312 to 0.116 captures the true difference in proportions of patients like these who would report reduced pain after taking naproxen and Valium versus taking naproxen and a placebo. There you go. Now, how important is that to you? I don't know, but let's read the next question. Based on the confidence interval in Part A, what conclusions would you make about whether Valium, along with naproxen, affects pain relief, and justify your answer? Now remember that interval, go back a slide, went from negative 0.312 to positive 0.116. So because the interval includes 0 as a plausible value, meaning that there's no difference, we don't have convincing evidence that taking the Valium along with naproxen is going to affect their pain relief. So to use some old terms, we would probably conclude this as being not significant or not convincing evidence. Never suggest that you believe the difference between the true proportions is 0 just because 0 is in the interval. So notice we didn't say there is no difference. We just said that since 0 was included within the 99% confidence interval, we don't have convincing evidence that there's a difference. I know. Word play. It's difficult on this test, isn't it? Now, I don't know about you, but I really didn't enjoy doing that one by hand. So good news. Your 8384 calculator can help you find the difference in proportions for a confidence interval. It is called a two-proportion z-test. And remember, when we were doing that by hand, that was actually the first thing we did. We're going to use a two-proportion z-test, which is what we're doing here. Now on the calculator, and that's in the test menu, it flat out asks you for the statistics from your study. So 39 out of 57 and 43 out of 55 at a 99% confidence interval, and then you just wham, calculate. It gives you the confidence interval. It ends up breaking it down as p hat 1 and p hat 2, but they don't really need that for the confidence interval. Now, as far as AP exams go, if you specified that you were finding a two-proportion z-test using these statistics, and you came up with the interval and you could interpret it, that's all they really care about. Just remember that you have to not just copy what you write on your calculator, but write out what you're using for what parts. So the formula for the two-sample z-interval often leads to calculation errors. So your teacher, and she is, going to recommend your calculator's use of the two-proportion z-interval. Be sure to name the procedure, so two-sample z-interval for P1 minus P2, and then give the interval in the do step. So you don't have to go through all the calculations. However, if you were trying to be like a really thorough bird and you wanted to write the calculations down but still do it on the calculator for computation, I don't think there's anything wrong with that. But you kind of have to fudge your intermediate work in there. So just be careful. All right, we're going to have to check your understanding now. Let's try it. We got that Pew Research Center again. They asked independent random samples of working women and men how much they value job security. Of the 806 women, 709 said security was very or extremely important, compared to 802 out of the 944 men. Construct and interpret a 95% confidence interval for the difference in proportion of all working women and men who consider job security very or extremely important. So, pause the video. Try to come up with this. I highly suggest you write out all of your steps that they want from you. Check your conditions, because they didn't say just assume it. And then I'll show you the answers in a moment. Okay, here comes the answers. So first, we have to state what we're doing. So we're looking for a 95% confidence interval for P1 minus P2, where P1 is the true proportion of working women who say that their job security is very or extremely important, and P2 is the true proportion of working men. Make sure this is not the sample, but the population parameter that we're looking for here. So now we're going to plan it, and we're going to do a two-sample z-interval for P1 minus P2. But before we do the work, we have to check all the three conditions. So it is random because they stated that the data was from independent random samples. We checked the 10% condition. So this time, I don't know why they didn't bother saying that thing about not being without replacement, but anyways, 806 is less than 10% of all the working women, and 944 is less than 10% of all the working men. And then the large counts condition. Remember, there's 709, quote, winners in the women category, which means there's 97 not winners. I should say success and failure. And then 802 success for men and 142 failure for men. All of those numbers are greater than 10, so all three conditions are met. Now for the do step, you do not have to do all this calculation if you're using your calculator. However, you do need to write that I used my TI-84 calculator, chose two proportion z interval, and then give the interval. Either way, you do end up with the exact same confidence interval. So now we must interpret that, and we say we are 95% confident that the interval from negative 0.002 to 0.062 captures the true difference in proportion of all working women and all working men who would say that job security is very or extremely important. So they didn't ask us to go further to say if we had convincing evidence, but once again, 0 is a plausible number in this confidence interval. So we don't necessarily have convincing evidence that there is a difference in proportions. And that's it. That was all of chapter 8. I know it felt like a lot, and it really was. We're going to get used to answering those questions on our AP practice questions and also using technology when appropriate, which is going to be quite a bit during this chapter. All right, good luck.